Good day, everyone. We have a passive paradise to show you today. Look at this guy. It's a 3,500 square foot house, our Frontenac model. There's 4 bedrooms, 4 washrooms in this house. We're gonna go in to check it out. But looking at this from the outside, you really see all of the design possibilities, all of the passive possibilities in this house from a design perspective and an operational perspective are happening. Let's go and check it out. First, let's look at these nice passive doors. These doors are from an Irish company called Munster Joinery. You can see they offer a nice wood grain finish on the outside. Not everything has to be white, but this house called for a white interior. But really good to look at the frame here. There's a 3-part frame system. So all windows, doors, just like the walls, need to be thermal bridge free. It's a passive house requirement, prerequisite. But you can see the exterior frame with the nice wood grain. There's an interior frame with the nice white. And right here in the middle, glass being on the opposite side, is a thermal bridge free part of the frame. So 3 parts together, thermal bridge free, very strong system. Multi-point hardware is common for any passive door. You can see when the door is in lock position, all the different locking mechanisms as part of the side, which allow when the door is pushed closed, the multi-point system engaged, really presses the gasket right up against the frame, so air leakage is impossible. Okay, so nice wide entrance, 8 feet wide, 10 feet deep, really grand entrance. Nice closet here, tucked off to the side, sunk in the walls. It allows for a nice clean entryway. We have a powder room right here by the entry door, which is the first washroom. There's 4 washrooms total in this house, and a strategically placed utility room communicating all of the passive possibilities from an operational point of view are in this room right here. And everything is even within a 50 square foot space. We have all the utilities. There's also going to be a laundry room in here. And the owner of this house is an electrical engineer. He's a sustainability advocate, passive house advocate. And the reason why we have all different systems in here is to compare the operation of how they are all working. So let's break it down. Up here, we have our passive certified ERV system, certified component, Jablotron Futura. This machine is responsible for all of the fresh air requirement of the home. It extracts 90% of the heat energy out of the stale air leaving the house, transfers that to the incoming cold air. This is done at minus 15 degrees Celsius, so very energy efficient with respect to that. Helps maintain, a highly oxygenated environment on the inside. There's fresh air inlets delivered to every living space of the home. Alternatively, exhaust is done from all the wet areas in the home. So the kitchen, all the washrooms, laundry spaces, utility spaces receive exhaust vents. All of the air comes into a passive home through a single pipe and exhaust through a single pipe as well. You can see the pipes up there, the insulated pipes. Also this machine, because of the piping and how it's strategically placed in the wall system, creates or allows for a dust-free environment. Most homes that have combustion appliances or conventional fresh air machines, those exhausts and supply air vents come out of the building close to the ground where all the dust happens. In a passive home, we want to put those pipes outside, above, high up in the wall system, so that there's no chance for unnecessary dust come in the machine. When it comes down to it, the filters will deal with that dust no problem. These filters can sometimes last up to a year on a couple single filters for the supply and the exhaust. So really an incredible machine. From an operational point of view, what's great is this application that the machine comes with. You can monitor the inside temperature, the humidity of the house, the carbon dioxide levels. Most of our customers, they control this machine based off of the carbon dioxide and the humidity levels. So it's been proven that below 1,000 parts per million with respect to carbon dioxide, the house is healthy. Keeps the indoor air quality optimal. Okay, some people want that to be closer to 500 parts per million. No problem, just choose a fan setting that is going to allow for that. Also, humidity. You know, humidity inside our homes for optimal health needs to be between 40 and 60% humidity. This machine, any certified passive machine, keeps the house within that 40 to 60% zone year round, regardless of the outside climatic condition. It's a ERV, energy recovery ventilator. There's a drain that it allows excess moisture to be removed from the air, or the moisture is kept inside the home if it is on the closer to the 40% side of the humidity. Beneath it, we have a standard electric water tank. So this water tank is connected to all the plumbing in the building. It is going to be used in a comparison basis to compare the cost with respect to this water heater versus an instantaneous water heater, which you can see mounted high up on the wall here. SustainableLiving instantaneous electric operated water heater. So we'll be able to compare the usage between standard electric, instantaneous, find out which one is better. We have another electric boiler, but this electric boiler is dedicated strictly for hydronic floor heating system. So there's a hydronic floor on the main floor of this slab-on grade house. There's also a hydronic floor on the second floor, which we will be checking out shortly. So this house can be entirely heated separately by the hydronic floor system. There's also a heating and cooling heat pump system that we're going to be showing you as well. So you can see pressure tank, part of the hydronic system. The well, the water service for this house is done by a drilled well. You can see a standard pressure tank here sitting on the floor, and in front of it, a water conditioning system to take care of purification of the water. And lastly, we have our electrical panel, 200 amp service, standard electric service, does everything in this passive house. In the back of this utility room, there will be a future washer and dryer here, all done within 50 square feet. Okay, so walking into the main area of this house, first we have the kitchen. Even though this is a large house, compact kitchen, 10 feet wide, 10 feet long, 100 square feet, but look at all this counter space. You know, lots of workspace, glass in some of the cabinet doors help keep the open, modern theme that this kitchen has. Beautiful stone countertop. And, you know, nothing real passive in the kitchen, but Energy Star, all Energy Star appliances, jump onto the Energy Star website where you can easily, at the click of a button, find the most efficient appliances available at any given time. Keeping in the front of the home, into the first bedroom, a compact bedroom, couple windows, could also be a secondary office space. There's an interior window that will be going in this opening as well, okay, which will be opaque frosted glass. Mini split, so our first mini split system. This home has a number of different mini splits, ultimately one in each bedroom space. Now into the main living area on the main floor. This is about a 450 square foot space, accommodated dining room, nice open living room. There's double doors leading out onto this beautiful backyard. Okay, really open, lots of glass in this house, allowing all the natural daylight to come in so that lights don't need to be on during the daytime. Lots of glass. We're on one of the wings of the house. This is the west wing, mini split up on the wall. You can see fresh air inlet in the back wall. This is about a 200 square foot space. Okay, there is a secondary bedroom here in the end. Okay, so same concept as the other side. There's going to be an open interior window placed in here. This bedroom has its own compact washroom. There's a stand-up shower in there, toilet, compact sink as well. There is the east wing as well. This is the third bedroom that's contained on the main floor. So large room, could be a very large working office as well. Mini split for its own heating and cooling abilities as well. So we're in the loft. This is ultimately the largest living space the house has. We're about 30 feet long, 20 feet wide, so about 600 square feet. Could be a huge games room or a shared living space if there were a couple suites integrated into the wings of the house. Could be a kids room, a lot of possibilities here. Okay, so let's look at these windows. These windows, you know, when the handle is horizontal, the top tilts open, so it provides like a partial ventilation, also very good for security. Handle turned all the way up. Window opens up complete for maximum ventilation possibility. Similar to the doors, there's an exterior frame. You can see the nice wood grain. There's an interior frame as well. Right in the center where the glass is located, there's a thermal bridge part of the frame to maintain the thermal bridge protection that a window needs, similar to the rest of the house. So the passive house is not compromised, of course. But look at the glass. Look at the thickness of the spaces between the glass. Triple glazed glass, of course, but these spaces are almost an inch thick. Okay, so compared to your conventional window, very small air spaces, closer to a ½ inch, so about double the vacuum airspace is one of the qualities that these windows have, which is the reason why they are considered a super insulated glass unit, similar to the walls and the rest of the home. Okay, so these windows truly maintain the thermal envelope of the house. They're rated at an equivalent R12. Most conventional triple glazed windows, you know, are rated at an R4, R4.5. Small air spaces really aren't that efficient when you compare it to the bulletproof nature of a passive home. These windows also have a very high solar heat gain coefficient. When the sun is at a low angle, all that free sunlight rips right into the building. Now, talking about thermal envelope, here's a good picture of how thick the walls are. Okay, so this interior sill is about 13 inches. You know, kept at the right height, it becomes a piece of furniture. But this is a good indicator of the thickness of the walls. We have about a 12 to 13 inch interior. There's a 7-inch exterior, and we have the window integrated into that wall system as well. You know, we often get told or asked the question, why do these walls need to be so thick? You know, these walls, we refer to them as the thick-ass wall, of course, because that's what's needed to maintain a passive envelope in northern climates. So what's in these thick-ass walls? Ultimately 20 inches of cellulose insulation. There's an inside frame, there's an outside frame, there's integrated water barriers, air barriers, vapor barriers. There's a couple different sheathings in this wall system to make the house strong and, you know, ultimately strong enough to deal with these changing weather patterns that we're experiencing. Tornado-proof, hurricane-proof house is what we mean when we call the house resilient. Also airtight. We'll go more in depth on the wall assembly a little later in this video. This house is approximately 3,400 square feet total, 1,800 square foot on the main floor, 1,600 square foot on the second floor. You know, there's a number of different mini split heads up on the wall in this house, but from a minimalistic approach, if someone wanted to use the minimal amount of heating and cooling mechanicals in the home, a single mini split per floor is all that's required in a passive home, any passive home. Okay, moving into the west wing. Here, similar to the main floor, there's a bedroom space. This bedroom's a little bit larger, about 250 square feet. Own mini split up on the wall. Fresh air inlet as well that every living space has. This room could be its own compact living space. It could be an entirely separate suite as well. Nice ensuite washroom. There's a large soaker tub in there. There is also a shower space and a double sink. Onto the far side of the house, see a nice beautiful window, keeping with the open concept, natural light that this design provides. Many windows, keeping it modern. Onto the other wing of the house, another bedroom. This ultimately completes the 5th bedroom in the house. Large walk-in closet. Ultra large walk-in ensuite washroom as well. Oh, look at this washroom. Like, man, there's everything in here. Jacuzzi tub, 6-foot jacuzzi tub, very large walk-in shower, Jack and Jill sink, and it's got it all in there. Okay, really cool. This master bedroom has its own rooftop patio. So opening up these double doors, nice robust double doors, about 750 square foot rooftop patio space. There's a hot tub tucked into the corner. Big party could be happening out here, or it could simply be a spot to relax and enjoy the peaceful surroundings that this house has to offer. Okay, let's get ultra serious for a minute. Look at this wall system. This is how a code-built home gets built ultimately. We have exterior sheathing, 2x6 wall cavity. There will be a batt type of insulation, an R22 batt will go in here. It'll get covered with a vapor barrier, covered with drywall interior finish. This is how code-built homes get built. It's the way that a garage gets built in a passive home. So let's think about that for a second. We're standing in the garage. Code-built homes are built the same way as a garage gets built. How crazy is that? It drives the point home, you know, that conventional wall systems, code-built wall systems, are simply buildings that are designed for the past. That conventional wall assembly is now a standard garage wall assembly, and that's where it should be done, and done only in the garage. Now let's go check out the passive envelope. Okay, the way all homes will be designed and built in the near future. You know, for simplicity purposes, the inside wall, the load-bearing wall of the passive home gets built the same as that conventional system, simply for the load-bearing wall, simply for a little bit of extra insulation. This exterior wall, 14 inches in this case, because is where it's called for in northern climates. This is your passive wall. That is thermal bridge-free wall. It contains an additional total R75 level of insulation when you factor in this wall and the interior wall. So R75 compared to R22. The way it gets built, there's a structural sheathing vapor barrier separated from an exterior structural sheathing air barrier, which is also the open permeable nature of a passive home. You know, PassiveHouse is the only construction model in the world where building science is part of the equation. The way houses get built, you know, with their typical code-built homes, we have exterior sheathing on the outside, which is technically a vapor barrier. And then we have a plastic vapor barrier put on the inside. So there's a moisture trap, vapor barriers on both sides. Passive assemblies, alternatively, are built to be open permeable. Why? Because anyone in the construction world knows there's a ton of moisture in this wall as the house gets built. Wood is sold at 18% moisture content. That's considered dry construction material. 5 years down the road, that wood is now 5% moisture content. Where's all that moisture go? In a conventional home with a moisture trap, it will lead to mold growth in very few years potentially. In a passive home, all that moisture is allowed to be absorbed by the exterior fiberboard and driven to the outside of the home. Okay, Not everyone's building passive houses the same, okay? In many passive homes, people are putting simply a house wrap on the outside, eliminating the sheathing, because a single layer of sheathing is all that's required for standard engineering, standard strength of the house. But our belief is that the house also has to be built resilient, okay? Sustainable building calls for resilient construction, strong construction. Passive house, due to the nature of the home, requirements for vapor tightness, air tightness, water tightness, allow extra structural sheathings to be implemented into the design very easily. Okay, so 2 layers of sheathings in the wall, 3 layers of sheathings in the roof system. Tornado-proof, hurricane-proof house is the result. So what goes into the wall assembly? Interior load-bearing wall, 2x6 wall, structural vapor barrier sheathing, non-load-bearing passive wall assembly. Cellulose gets dense packed at 3.5 pounds per cubic foot, which is proven the insulation will not settle. Exterior open permeable air barrier sheathing, exterior water barrier house wrap, all working with the permeabilities that are required for the different climate zones where you may be building. You know, I'm standing in the door of this 3,400 square foot house. How much does it cost to insulate? You know, someone might think that's cost prohibitive. How much does it cost to insulate these walls to R75, the roof to R110? Less than $40,000. This is a huge 3,400 square foot home. Compare that to a code house that might use more expensive fiberglass, rock wool, spray foam. Guaranteed that cost is going to be very similar, but the difference is the walls are R22 full of thermal bridging. The roof is an R36 full of thermal bridging as well. Simply not the way to do things. You know, these homes are going to be code in very few years from now. Protect your investment and build yours today. So we want to say welcome to all the new subscribers. Thanks for joining. We hope you like what you see, and we hope you enjoyed this tour, this walkthrough of the Frontenac model, 3,400 square feet, 5 bedroom, you know, really a house plan with all possibilities. We want to hear from you though. You have any suggestions, tips, comments? What do you want to see more of? Let us know. Don't forget to like and subscribe, and stay tuned for more.